Most comets we know follow graceful, looping paths around the Sun. They glide along elliptical orbits, returning again and again, sometimes after just a few years, sometimes after thousands. But 3I, Atlas is different. This isn't a comet that belongs to us. It doesn't circle our Sun at all. Instead, it travels on a one-way, hyperbolic path, an open curve that guarantees it will never return. So why does 3I, Atlas move differently than the comets we've studied for centuries? To answer that, we need to look at how orbits work, how fast this visitor is moving, where it came from, and why it shocked astronomers when they realized just how unusual its path really is. The shapes of orbits. Every orbit in the universe can be described as one of a few shapes: circles, ellipses, parabolas, or hyperbolas. Most comets in our solar system are bound by the Sun's gravity. They travel in ellipses, elongated circles that bring them closer to the Sun before flinging them back outward. That's why comets like Halley's return on schedule. Their orbits keep them tethered to the Sun. Now imagine pushing something just a little harder, enough that it reaches exactly the escape velocity. That object would follow a parabolic path, a perfect curve that never closes. But if you throw it even harder, faster than escape velocity, the orbit becomes hyperbolic. Instead of bending back around, the path shoots off forever. That's exactly what 3I, Atlas is doing. Its eccentricity, the measure of how stretched an orbit is far greater than 1. In other words, its path through the solar system is not a loop. It's a flyby, speeding through the solar system. When astronomers measured 3I, Atlas, they realized it was traveling more than 130,000 miles per hour, or about 210,000 kilometers per hour. That's far faster than the typical comets that originate in the Oort cloud or Kuiper belt. To put it in perspective, the Earth itself orbits the Sun at about 67,000 miles per hour. Even our fastest spacecraft would struggle to keep pace with 3I, Atlas. For comparison, Oumuamua, the first interstellar object discovered, sped through at nearly 196,000 kilometers per hour. 2I, Borisov, the second, was slower but still faster than ordinary comets. 3I, Atlas sits in between, but still far beyond the Sun's ability to hold it captive. That speed alone is enough to explain its hyperbolic trajectory. It simply has too much momentum to be caught. How astronomers tracked its path. 3I, Atlas was first spotted in July 2025 by the Atlas Telescope Survey. At first, astronomers thought it was just another dim comet. But as more observations came in, the data told a different story. The comet's perihelion, the point of closest approach to the Sun, was calculated to occur in late October 2025, at a distance just inside Mars's orbit. After that, it would sweep back out, never to return. Its closest pass to Earth would come in mid-December, still a comfortable 270 million kilometers away. From there, it would fade into the black, beyond the reach of our instruments. By combining telescope images from Atlas, ZTF, and even pre-discovery data from earlier surveys, astronomers traced its orbit backward. The results confirmed it wasn't a solar system native. It came from beyond, and it was on its way back out. A different direction. One of the most surprising details about 3I, Atlas was the direction it arrived from. Many scientists expected interstellar visitors to come from a specific region of the sky, the so-called solar apex, the direction in which our Sun is moving through the galaxy. After all, if the solar system plows through the galaxy like a car on a highway, wouldn't most debris come from straight ahead? But 3I, Atlas came from a different angle, from the southern sky near Sagittarius, on a slightly tilted retrograde path. This was unexpected. It suggests interstellar objects don't all follow the same flow. Instead, they may be drifting in from many parts of the galaxy, each with its own origin story. This matters because it means the galaxy is more dynamic than we thought. Every star system is constantly ejecting material, asteroids, comets, debris, sending them in random directions. Some of those fragments eventually cross our path, carrying with them chemical signatures from alien nurseries. The one-way journey. Think about the difference between a comet like Halley's and 3I, Atlas. Halley's takes about 76 years to complete one orbit. It comes back predictably, like clockwork. You can mark your calendar for its return. 3I, Atlas, on the other hand, is a one-time guest. It entered our solar system on a hyperbolic path, and when it leaves, it's gone forever. That makes it a fleeting opportunity for science. Astronomers had only months to gather data before it faded. No spacecraft could possibly catch it. In fact, by the time it was discovered, it was already moving too fast and too far for us to mount any mission. This is why interstellar objects are so frustrating and so exciting. They give us only a narrow window of observation, but within that window lies a chance to study material that formed around distant stars billions of years ago. What its path reveals about origins. The hyperbolic orbit of 3I, Atlas tells us something about its past. Objects don't just appear on hyperbolic trajectories. They are launched. Somewhere in another star system, long ago, 3I, Atlas may have been part of a young planet-forming disk. A giant planet's gravity could have flung it outward. Or perhaps a close encounter with another star destabilized its orbit. Whatever the mechanism, it was ejected into interstellar space, doomed to wander. For billions of years, it drifted silently between the stars, until chance brought it near ours. Its hyperbolic motion is a signature of exile. Unlike comets bound to the sun, 3I, Atlas is bound to nothing. It is a citizen of the galaxy. Why it matters for astronomy. Every interstellar visitor teaches us something new. Oumuamua showed us that interstellar objects can look nothing like ordinary asteroids or comets. Borisov showed us that some look very much like familiar comets, though with subtle differences. Now 3I, Atlas adds a new layer. Its unusual direction, its high speed, and its unique chemistry all suggest a galaxy filled with diversity. Planetary systems are not identical copies. Each cooks up its own recipes of rock, ice, and gas. And when fragments from those systems wander into ours, they give us direct evidence of that diversity. It's like receiving packages from faraway kitchens, each containing different ingredients. The limits of what we can do right now. We don't have the ability to send spacecraft after fast interstellar comets like 3I, Atlas. By the time we spot them, they're already on their way out. But in the future, astronomers hope to change that. Proposals exist for rapid response missions, spacecraft that could be launched quickly to intercept the next interstellar object. These missions would need powerful propulsion systems and flexible designs, ready to chase a target on short notice. If we succeed, one day we might sample the dust of a comet born around another star. For now, though, telescopes are our only tools. We collect its light, split it into spectra, and decode what we can. Imagining the encounter. Picture yourself standing on a spacecraft, watching 3I, Atlas fly past. Its coma glows as sunlight vaporizes exotic ices. A long tail streams behind it, pointing away from the sun. You feel the speed, the sense of something ancient rushing by, untouchable. That image captures what astronomers feel when they watch such objects. It's awe, mixed with frustration, knowing this is a once-in-a-lifetime glimpse, and once it's gone for good. 3I, Atlas travels differently than other comets because it doesn't belong here. Its hyperbolic orbit is the mark of a wanderer from another world. Its speed ensures the sun cannot capture it. Its direction shows us the galaxy is filled with countless pathways, sending material into interstellar exile. By studying its path, we learn not only about this single comet, but about the processes that shape entire star systems. 3I, Atlas is more than a comet. It's a messenger, reminding us that the universe is alive with movement and exchange. It will never return. But the brief story it told us as it passed will linger, adding one more clue to the puzzle of how worlds are born, how they evolve, and how they sometimes cast their fragments into the stars.